Physical and chemical properties and changes. In this lesson, we're talking about what is matter, the states of matter, chemical versus physical properties, qualitative versus qualitative properties, chemical versus physical change, and energy. Matter. So matter makes up everything in the universe. It makes up everything from chemistry, biology, astronomy, physics, and earth science. Everything that is not energy is matter. The definition of matter is any substance that has both mass, collection of particles, and volume. It takes up space. Almost everything around us is matter, including air and other gases. Energy, however, is not matter. Energy doesn't have mass or volume, and therefore we can't classify it as matter. There are three main states of matter: solid, liquid, and gases, and you can see the difference between the three. Solid particles are much closer together, and they're going to move a lot less. Liquid particles are a little further apart, and their movement is a little bit more, and gas particles are moving really quickly and are really far apart. So let's go through a few more properties of them. When we're talking about atomic/molecular motion, solid particles don't vibrate very much. We say they vibrate about a fixed point. So if you have a particle, it's going to move a little bit, but it's not going to move very much. Liquids are going to be more free to move. If you pour water into a glass, those liquids are going to fill the entire glass. And that's similar to gases. Gases are also free to move. So if you release a canister of gas into the air, those gas particles are going to go in every direction. They're going to fill the space that they're put into. Solid particles are very close together. So as I showed right here, the particles are much closer than their liquid or gas counterparts. Gas counterparts are really far apart. They have the most motion, and they're going to fill the space that they're in. So they're going to be the furthest apart. The shape. Solid has a definite shape. But think of an ice cube. So if you have an ice cube and you put it into a glass, it's going to stay in the shape of an ice cube. Whereas a liquid is going to be more like this picture right here. The liquid is going to fill the container, and a gas particle is going to do the same thing. The gas particle, instead of filling the liquid glass container, if you pour a gas into a cup, it's going to fill up the cup, but it's also going to fill out the entire room as well. In terms of volume, if you take a look at a cube of ice, it's going to have a particular volume based on the dimensions. So if it's 1 by 1 by 1, it's going to have a volume of 1 centimeters cubed, or you could say it's 1 milliliter in volume. Liquid is going to have the same thing. So if you have 15 milliliters of something, it's going to be 15 milliliters no matter the container that it's in. However, a gas, since it spreads out throughout the entire room, its volume is dependent on the container that it's put into. So if the container is really big, the volume gets bigger. If the container is small, the volume gets smaller. Compressibility refers to how much can we push the particles together. Since solid particles are already very close together, we can't really compress them, so we say that they're not compressible. Liquid particles we can compress a little bit, and gas particles, since they're so far apart, we can push them back into a small container. So if you think of like a scuba diving container, you're going to put a lot of gas particles that would otherwise fill a room into a very small container. Now these three states, solid, gas, and liquid, are interchangeable. So if you go from gas to liquid, that's known as condensation. If you go from liquid to gas, we say it's vaporized. Solid to liquid would be melting, like you put an ice cube in a cup and let it melt. And if you go from liquid to solid, like putting liquid water into the freezer, it's going to freeze. If you go from solid to gas, it's called deposition. And if you go from gas to solid, it's going to be called sublimation. Properties. Properties are the characteristics used to identify a substance. Examples include color, taste, smell, dimension, density, etc. So what are the properties of this particular vehicle here? I want you to pause the video and make a list of 3 or 4 properties of this vehicle. Properties could be that it's white. You could say that the wheels are black. You could say that it's heavy. You could say that it's hard, etc. There's lots of properties that would go along with this particular vehicle. Types of properties: chemical and physical properties, and quantitative and qualitative properties. These properties are not mutually exclusive, i.e. they can overlap. So for instance, a physical property can also be a qualitative property. Chemical properties. A characteristic is considered a chemical property if it describes the ability to react with another substance and form one or more new substances. So for example, iron rust. This is a chemical property as iron has the potential to change into a new substance, rust. So if we go from iron to rust, we're changing the chemical composition. They are not the same at the chemical level. So it's actually a new substance being formed. And that's what we're looking for. If a new substance can be formed based on some kind of chemical reaction, this is a chemical property. Physical properties. A characteristic is considered a physical property if it can be observed and or measured without a new substance being formed. And that is the main difference. We talked about a new substance for the chemical properties, physical property, no new substance. So for example, freezing point of water. When water changes state, a new substance isn't created. It's still H2O. You're going from H2O to H2O. It's still H2O at the molecular level, and therefore it's a physical property. Observing going from liquid to solid doesn't actually change the chemical composition of the molecule. So here's some examples, some physical and chemical properties for gold. Gold is solid at room temperature. It's yellow, has a density of 19.3. Its melting point is 693 degrees Celsius, and it's a good conductor of electricity. These are all our physical properties. They're physical properties because they're describing the physical nature of the substance. The chemical property is the reactivity to acid. Since it can react with acid and will form a new substance as a result, that is a chemical property. So what do you think dissolves in water is? Is that a chemical or physical property? It's actually a Physical property. Dissolving in water doesn't change the molecular structure of the atoms involved. You're just simply going to break them apart. For instance, if you put sugar into water, your sugar molecules are going to break apart, but they're still going to be sugar molecules. And instead of two sugar molecules being put together, you're going to have sugar, and you're going to surround them with H2O. And that H2O is going to keep the sugar molecules apart, which will be observed as a mixing between the sugar and the water molecules. And we say that the sugar at that point has been dissolved in the water. It's still a sugar molecule and a sugar molecule. The actual chemical composition of the sugar hasn't changed as a result of being added to the water. Qualitative versus quantitative properties. Subgroups of physical properties include qualitative properties and quantitative. Qualitative properties are descriptive properties, i.e. the car is red. A quantitative property is based on a quantity, a number. So for instance, it's 35 degrees Celsius outside. That's a quantitative property. It's still a physical property, as is qualitative, but they're their own subgroups as well. So here's some common physical properties. Viscosity, melting, freezing point, boiling point, solubility, hardness, conductivity, density, color, odor, state, texture, and malleability. These are all common physical properties. Common chemical properties would include reaction with an acid, reaction with another substance, combustibility, which is reaction with oxygen, and the ability to rust. You'll notice all of these are a reaction. Check your understanding. Identify the type or types of properties for the following. Food rots, an acid corrodes a metal, and the weight of a gallon of oil is 7.5 pounds. So I want you to pause the video and answer numbers 1, 2, and 3. Number 1, food rots. This is a chemical property as a new substance is formed. All the gross things that you see when food rots are actually new substances being formed. So the food is being changed from the initial food to a new kind of food, and as a result, a chemical reaction has occurred. Number 2, an acid corrodes metal. This is a chemical property as the acid and the metal are destroyed in observing this property. So for instance, iron plus sulfuric acid is going to give us iron sulfate and hydrogen gas. The weight of a gallon of oil is 7.5 pounds. This is a physical property as the oil is not changed in making the observation, and more specifically, it's a quantitative property since a measurement is involved. Chemical versus physical change. A chemical change results in a new substance with different properties, a change in the molecular structure. A physical change may change the appearance of a substance, but there will be no new substance formed. No change in molecular structure. So here are a few comparisons. Burning wood versus sawing wood. Sawing wood is a physical change because we're just taking a big piece of wood and breaking it into small pieces of wood, but it's still wood. Burning wood changes our wood into a new substance, so that's going to be key. Decomposing water. We're taking H2O and breaking it into hydrogen gas and oxygen gas. These are new substances. Freezing water is taking H2O and leaving it as H2O, just in a different state. Iron rusting is taking iron and making it into a new substance. Cleaning rust with steel wool is simply removing the iron from the outside of the metal. You're not changing the composition of the metal, you're just removing the rust from on top of it. So how do you know if it's a chemical or physical change? Well, some chemical change clues include change in temperature, change in color, a noticeable odor, formation of precipitate. Precipitate is simply a solid being formed, and that solid is generally a new substance, and the formation of bubbles. Also, a difficulty in reversing a change hints at a chemical change. However, you need to keep in mind that these are only clues, and that a chemical change may have taken place. Proof still depends on a new substance being formed with new properties. Energy is not matter. It has no mass and takes up no space. It is the ability to do work and comes in many different forms, including heat, mechanical, electrical, sound, chemical, nuclear, and electromagnetic. So energy is the ability for us to do something. For instance, nuclear energy allows us to create electricity, which allows us to run our gadgets at home. Heat energy allows us to boil water to change it from a solid to a liquid to a gas. So energy allows us to do something, but it is not matter in itself. And that concludes our lesson on physical and chemical properties and changes.